Hey everyone, welcome back to Prep with Sid, where we break down technical interview questions step by step and focus on the thinking behind the solution. Today, we are going to solve a very common SQL interview pattern called the gaps and islands problem. These problems show up often in interviews because they test whether you can identify consecutive events or sequence in data. The question we are solving today is find each user's longest streak of consecutive login days. We need to return the user ID and the longest streak days. There's one important detail in the question. A user may log in multiple times on the same day. That detail matters because if we don't handle duplicate login dates first, we may accidentally overcount a streak. Let's start by creating a table. We'll create a table called user logins with three columns: login ID, user ID, and login date. Okay, our table got created. Now let's insert some sample data. The sample data has a few different users with different login patterns. Some dates are consecutive, some dates have gaps, and some users have multiple logins on the same day. For example, you can see user 103 has 2 logins on January 10th. That makes this a good example for a gaps and islands problem. Now let's take a look at the raw data. Here, we can see the login events ordered by user ID and login date. For user 101, we have January 1st, January 2nd, January 3rd, then a gap, January 5th, and January 6th. So user 1 has one streak of 3 days, another streak of 2 days. For user 103, we have a duplicate logins on January 10th and then January 11th. The duplicate date should not make the streak longer. So user 103 should have a longer streak of 2 days. Now let's solve this step by step. Step 1 is to remove duplicate logins on the same day. We only care whether user logged in on a date, not how many times they logged in on that date. We'll create a CTE called distinct logins. Inside the CTE, we will do select distinct on user ID and login date from user logins table. Let's move to step 2, which is to assign a row number to each user's login dates. For this, create a CTE named numbered logins, and here we'll assign a row number partitioned by user ID and order by login date. Partition by user ID means each user gets their own sequence. Order by login date means the dates are numbered in chronological order. Now let's select from numbered logins and check the output. You can see for each user, we now have login date and the row number. You'll see in the next step how this row number allows us to identify a group of logins. Now step 3 is the main gaps and islands trick. Pay attention. Here we create a group key by subtracting the row number from the login date. Let's create a CTE called grouped logins. Here we will select user ID, login date, and using date add to subtract row number from the login date. The reason this works is because for consecutive dates, the date and the row number move together. For example, January 1st with the row number 1, January 2nd with the row number 2, and January 3rd with row number 3 all produce the same adjusted date. That same adjusted date becomes the streak group. To see that, let's select from grouped logins and look at the output. This is the most important result to understand. For consecutive dates, the streak group stays the same. When there's a gap in the dates, the streak group changes. The streak group column may look like a date, but think of it as a key. Okay, so now we have converted the problem from find consecutive dates into a simple grouping problem because you have a key. In step 4, we'll count the length of each streak. Create a CTE named streak in which we select user ID, streak group, and count the number of rows from grouped login. Group by user ID and streak group. We are counting the rows in each group, and that count becomes the streak length. Now let's select from streaks and check the result. At this point, we can see all streaks for each user. For example, user 101 should have a streak of 3 and a streak of 2. User 102 have a streak of 3, and user 103 have a streak of 2. Now the final step is simple. Since our question asks longest streak per user, we just take the maximum streak length for each user. That gives us each user's longest streak of consecutive login days. So finally, we select user ID, max streak length as longest streak days from streak, Group by user ID. We can also order by user ID to see users in order. This gives us the final output. User 101 has the longest streak of 3 days, 102 has the longest streak of 3 days, and 103 has the longest streak of 2 days. So that is our final solution. Now there could be a follow-up question or slight variation from our original question, which is find the user with the longest streak. Pay attention, we are asking for the user with the longest streak, meaning your result is just one row. I want you to think about the solution. I'll give you a clue. We're 90% there. Clue is that we just need to add a way where we can figure out which streak is the longest. Try it out. Let's summarize gaps and islands topic from today. The big idea to remember is that for gaps and islands problem involving consecutive days, one common pattern is to use row number and create a grouping key using date minus row number. Once you have that group key, the rest becomes normal aggregation. This pattern is useful for login streaks, purchase streaks, active subscription days, consecutive transactions, and many other interview style problems. Netflix may ask, tell us the longest watching streak, which is exactly the same pattern. Hopefully, this made the gaps and islands pattern feel a little more intuitive. The more SQL problems you break down this way, the more patterns you will start recognizing naturally. And once you start recognizing the patterns, the SQL becomes much easier. Thank you. I'll see you in the next one.